Time for our first NTP lab, and here we're going to make router 1 the NTP server really with R2 as its only client, and you'll see in a moment why we still use the term NTP master for the master device here, but in effect it is our server. Let's go ahead and check these clocks out first though. In router 1 you always want to check the clock of a device that you're going to make an NTP master, and I can vouch for router 1 that is the correct time. Router 2 there needs a little bit of help because it thinks it's New Year's Day 2001, so we need to bring that baby up to date. Let's go up to router 1 and start making that happen. One small disappointment here: you cannot make a Cisco router into an atomic clock with the command NTP master 0 because there is no command NTP master 0. Rats. Well, anyway, we are limited to the stratums 1 through 15 here on a Cisco router. And notice that this is a legal command by itself. So I think we'll leave it at the legal command there without specifying a stratum number, and that way we'll see what the defaults are. This is the only command we actually need to make this an NTP master device. Let's go down to 2 and have a look at our commands here, because one command you won't see here is NTP client, even though router 2 is going to be an NTP client. So what command do we use? We actually use NTP server here. Technically iOS help is correct. It's a little misleading in my humble opinion. When it says configure NTP server, I'm not actually configuring the server. I am pointing this client to the server. That's what we're actually doing with this command. So NTP server 12.123.1. And really here we're done. I want to show you one option here that I want you to know about, and that's prefer. Because of course we love redundancy, and we would love it if router 2 had 3 NTP servers to choose from on our network. And the thing is, you can configure multiple servers. You could just put NTP server in again. They would be separate commands. You don't put them all on one line. But you just put in, 123.1, then 123.3, then 123.4, wherever the servers are. But you may have one that you want to prefer over the others. And that's where the prefer option came in. So if I had another NTP server here, it was 172.12.123.3, but I preferred it to use .1 here, I would simply put prefer right there. And that's all there is to it. It's going to use .1 as long as it can. So really, that's it for our server config. So this config is about as easy as it gets. We just saw a timestamp message, and this is what I was try that again. This is what I was telling you about the timestamps. For the course to this point, I have left the timestamps off because I wanted us just to be able to concentrate on the messages and the syslog, system messages and the debug messages. But I left them on this time because I wanted you to see them. And this is one format. I will show you some other ones later in the course. But we can also see that it still says January 1. So it's not like this is going to take place immediately, the synchronization. One thing with NTP, it does teach you patience, even in a lab environment, because the commands are quick, but it may be more than a few minutes before the synchronization actually fully takes place. And we may well see that just here in our lab. Let me introduce you to a couple of really important NTP commands. And the first one being show NTP associations. And here, this is the master device. So when we look at what NTP devices it's associated with, when you see 127.127.1.1, that's the loop back here. That means the association is with this device. The reference clock gives you a huge hint. You don't even have to buy a vowel for an A, because I know you know that LOCL stands for local. Notice the stratum here is 7. I'm just pointing that out for right now. And all of these numbers down here, don't sweat those. Those are for future studies. We don't need them right now. What we always need when it comes to our client-server relationships in NTP, including the server, is to see the asterisk and the squiggly. Call it whatever you want. I know that's not the official term, but that's what I'm going with. You want to see system peer, and in this particular case, you want to see configured, because we did configure it with the NTP master command. That is as opposed to someone else saying, hey, here's your role and here's your time. We may see one of those later in a later lab. But when we're setting up client-server NTP relationships, you have to see these two symbols next to the address before we know our job is done. On the master itself, you're going to see it really quick because the association is with itself. But with the other devices, with our clients, it may not be as quick. Let's run show NTP status. This is our second command. This is the key phrase. Clock is synchronized. That's what we want to see. Notice here it says stratum 8. That's the stratum, really the default stratum of the router itself. And remember, this stratum is 7 because that's the internal clock. So the router itself is seen as one layer down from its own internal clock on a master. I know. But what are you going to do? Those are the rules. That's what we got to go with. Reference again, when you see 127, 127, 11, we know that reference is a loopback clock. That's this device. So on router 1, everything's good. Now we need to go to our client, check things out, and we will start with show NTP status. And first thing we see is clock is unsynchronized. So this does take a while because the thing is with what 99.9% of the things we do in Cisco land, I mean when we enter something in a router or a switch, happens just like that, right? Well, that is not going to be the case with NTP. This is more real world than on your exam, but I don't want you to think in the real world when you set up NTP 5 seconds later all your clocks are going to be synced, because it doesn't work like that. When you see stratum of 16, that's another huge clue that things are not as they should be, and no reference clock at all. Well, if we don't have a reference clock, that's not good either. Let's run show NTP associations, and starting to look good here. Now notice that we do see our 2 symbols next to the NTP device we're associated with, which is 123.1. So that's good. We're getting somewhere. The reference clock and the stratum information here, remember, that's the information of the associated device, not the local device. So that's why we're seeing 127, 127, 11, because this is such a powerful command. It's even showing us where the associated device is getting its time from, and also what stratum it is. So progress has been made. What we've got to do, though, is wait for show NTP status to sync up. So what I'm going to do is go ahead and pause the video. It's probably going to be a few minutes, and then when you come back, I'll show you exactly what it looks like. We'll check the clock timeout, and we'll move on from there. And just a few seconds ago, you can see our last update was 3 seconds ago, and we are synced up now. So router 2 show NTP status, clock is synchronized. Notice the stratum is 9, so we're seeing that hierarchy in action. The hardware clock on router 1 is at stratum 7, the router itself at stratum 8, and now router 2 at stratum 9. And there's the reference. Let's go ahead and run show NTP associations, and we see everything we expect to see. We're actually seeing that before as far as the address, reference clock, and stratum. And of course the most important thing is show clock, and you can see now that that has indeed updated and we are synced up with router 1. What we're going to do next is set up a peering between routers 2 and 3 and start flowing the correct time throughout the rest of our network, and that is coming up next.